What's the difference between permutation and combination? So in this lesson, let's find out. Now let's look at permutation and combinations definition. So in permutation, it refers to the arrangement of objects where order matters. While for combination, it refers to the selection of items from a set. Order does not matter for combination. So you notice that for permutation and combination, it involves selection of items from a set. You can select one item from a set or many items or all the items from the set. But after you select for permutation, ordering them or arranging them does matter. So if you have red and blue versus blue and red, when you're permutating, they make a difference. For combination, what happens is you have a set, okay, containing many items, and you just want to choose a number of them, maybe just 2 of them. Okay, whether you choose red followed by blue or blue followed by red, it does not matter, because for combination, order does not matter. Alright, let me illustrate permutation and combination with these balls here. So now we have 12 colored balls. Alright, so we have 12 colored balls, and in permutation or in combination, we often want to select a number of items from this set. Okay, so now let's take a look at an example of permutation. Now let's assume I'm interested in permutation. So when we are permutating something, we want to choose all or a number of items from the set, okay, and then we want to arrange them in a certain order. Okay, so in terms of permutation, let's assume that I want to choose 3 balls from this set here. So I want to choose, for example, the blue ball and the black ball and maybe the yellow ball. Now I select the first, second, and third ball, and the first is blue, second is black, and the third is yellow. Does it make a difference if I were to select these 3 balls? Okay, but now what happens is I have black as the first ball, blue as the second ball, and yellow as the third ball. Are they considered different? Yes, because the first ball is now no longer blue, it is black, right? The second ball is no longer black, it is blue. So these two, although you have 3 same colored balls, but because order matters, so the blue, black followed by yellow ball is a different arrangement from the black, blue followed by the yellow ball. So therefore, in permutation, once the order change, it is considered a different arrangement. Now, let me use these balls to illustrate combination. Now, if you're interested in combination, basically, we just want to choose, and order does not matter. So an example would be, I want to choose this particular blue ball, this black ball, and this yellow ball. Okay, and because order does not matter, as long I choose this particular blue, this black, and this yellow ball, it is considered one case. It doesn't matter how I put them, because for combination, I'm just interested in what is being chosen. Okay, subsequently, how I order them or how I arrange them does not matter in combination. So, to summarize what we have learned, permutation refers to the arrangement of objects where order matters. So, examples would include number of ways of arranging 5 students. Okay, sometimes this is less obvious. Number of ways of selecting a chairman, a vice chairman, and a secretary from a group of 50 students. So you have 50 students, you want to choose 3. Okay, and you can think of the chairman as the first position, the vice chairman as the second position, and the secretary as a third position. Okay, so choosing someone as, so if I have 3 similar students that are being chosen, if I put
person A as a chairman, person B as a vice chairman, and person C as a secretary, it is different from having person B as a chairman, person A as a vice chairman, and person C as the secretary. So when you are selecting people or selecting things and you are giving them different positions or different roles, okay, then that is considered a permutation. All right. For combination, we are selecting items from a set and order does not matter. Okay, so for combination, order does not matter. So for instance, we want to select 3 dishes out of a menu with 20 dishes. So this is a combination because it doesn't matter which dish we select first, second, or third. Okay. Select 3 student leaders from a group of 50 students. So out of the 50 students, I'm going to select 3 student leaders, okay? And they are all going to be student leaders. I'm not differentiating them as chairman, vice chairman, or secretary, or other roles. So they are considered similar. So in this case, order doesn't matter. So this would be a combination, okay? This would be an example of a combination.